Hello and welcome to another GCSE walkthrough, and in this video we're going to go through the last of the higher tier papers, so paper 3, which is also another calculator paper. So as always, click on the link in the video description which takes you straight to the paper, and it's good to print them off. If you can't print it off, you can just go along on the screen. And again, hopefully this helps you for your last maths paper. So all the best, and let's get cracking. So question 1, the frequency table shows the heights in centimetres of some tomato plants. So it looks like there were 7 tomato plants that were between 140 and 150 centimetres, and so on and so forth. Draw a frequency polygon to show this information. So a frequency polygon is like a line graph. So what we do is, if we take the first row, there were 7 tomato plants that had a height of between 140 and 150 centimetres. So what we do is we take the midpoint of our interval, which is 145 centimetres. So we find 145 centimetres on our x-axis, and we go up to 7, and it looks like every 2 small squares will be 1 tomato plant. So if this is 5, this is 6, this is 7, and so if we just mark that point there, that's the first one, and we just do that for all of our intervals. So the next interval is 150 to 160. So again, we take the midpoint, which is 155, and we go up to 10, is here. Now the next one, the midpoint is 165. And this time we're going to go up to 15, is here. Next one, the midpoint is 175, and we're going to go up to 19. So if that's 20, it's 2 squares below 20, is here. And finally, the last one, the midpoint is 185, and we're going to go up to 9, which is here. Now, once we've plotted all of our points, we need to connect them with a straight line. So if we get our ruler tool out, so we're going to connect all of the points. Okay. So make sure you use a ruler for this. It takes me a bit longer because I have to pick up the line tool every time I draw a line. And then down to the last one. And we are done. We have created our frequency polygon. So the most important things here are to, first of all, use the midpoint of our intervals, and then connect all of the points with a straight line. Question 2, banana computers. I think they're trying to rip off Apple computers there, but we'll just go with it. Banana computers sold 19.3 million computers in 2017. In 2018, they sold 18.2 million computers. So they're not doing as well in 2018. Work out the percentage decrease in the number of computers sold. Give your answer to 3 significant figures. So let's first of all work out what the decrease was, what the actual decrease was. So how many fewer computers did they sell in 2018 compared with 2017? Well, it's going to be 19.3 million. So 19.3 million. Take away 18.2 million. 18.2 million. That's going to be the difference. So I don't need a calculator for this. I can work that out as 1.1 million. So that is 1.1 million. Or if we were to write that out as a number, that would be 1,100,000. So that's how many fewer computers they sold in 2018. But we need to work out the percentage decrease. So to work out the percentage decrease, well, we take the actual decrease, which was 1.1 million, so 1,100,000, and we take that as a fraction out of the original amount they sold. So what did they sell in 2017? Well, they sold 19.3 million. So 19,300,000. So this would be the decrease as a proportion or as a fraction of the original amount. And then to convert that into a percentage, we just need to multiply this by 100. So I'm just going to get the calculator out. So 1,100,000 out of 19,300,000, and then times that by 100, and we get, and that gives us 5.69948. I'm just going to put ... because that keeps going on, and that is percent. Now, if we look at the final line, it says give your answer to 3 significant figures. So this is our first significant figure, this is our second significant figure, this is our third significant figure. So we're going to look at this digit here. So this is either going to round down to 5.69 or it's going to round up to 5.70, and the 9 tells us to round up. So it's going to round up to 5.70%. Question 3. The value of a house increased by 6%. The house then had a value of £265,000. So we don't know what it started off at, but we know that it increased by 6% and now the new value is £265,000. Work out the value of the house before the increase. So this is, the topic is reverse percentages, because we don't know the original price. That's what we're trying to work out. So the original price has to be 100%. And because the value of the house has increased by 6%, the new value, so the new value is now 106%. And hopefully you can see where I got this from. If the original price, we start at the original price of 100% and it's increased by 6%, it is now worth 106% of the original value. So we can say that 106% is equal to £265,000 because that's the value. Okay, so this is what it is as a percentage, but this is the value. And we're trying to work out the value of the house before the increase. So we're trying to work out how much it costs at 100%. So there's a few ways you could do this. The way I like to do it is, first of all, find 1%. So to work out what 1% is, we're going to divide by 106. So if we divide both sides by 106, so 265,000 divided by 106, that gives us £2,500. £2,500. And now we can work out what 100% is. We're just going to multiply it by 100. So we're going to multiply it by 100, and I don't need a calculator for this. I can see that is going to be £250,000. So that is our answer. Our answer is £250,000. And with reverse percentages, you can always check your answer. So let's say that the original value was £250,000. Okay. Now we know that it's been increased by 6%. So the multiplier is going to be 1.06. So if we multiply that by 1.06, we should get our new price of £265,000, which indeed we do. Okay, so with reverse percentages, always check your answer to see if you get back to the new value that's given in the question there. So our answer is £250,000. Question 4. We've got the formula S equals UT plus half AT squared, and we're given values for U, A and T. We need to work out the value of S. So what we're going to do is we're going to substitute our values for U, A and T into our formula to give us our value for S. So S is equal to U times T, so it's -5 times T, which is 3. And then we're going to add on a half times A, or A is 4, times T squared, or T is 3. So we're going to times that by 3 squared. And all we have to do is put this into a calculator. You could just work out what this is. But as we've got a calculator, let's just type it in. So -5 times 3. And then we're going to add on a half times 4 times 3 squared, and that gives us 3. So our answer, S equals 3. Okay, part B, make A the subject of this formula. Well, whenever it says make A the subject, we have to get A on its own. So our final answer has to be A equals. Okay, so first thing I'm going to do is just write out the formula again. So we've got S equals UT plus a half AT squared. Now I'm going to get rid of this UT first of all. So to get rid of the UT, I'm just going to take away UT from both sides. So when I do that, I'm left with S minus UT equals, now I've just got this, a half AT squared. Now if we get rid of the half, so in order to get rid of a half, we could just multiply both sides by 2. So let's just do that in red. So I'm going to multiply both sides by 2. So what am I left with? Well, I've just got 2 times all of this. So 2 lots of S minus UT. You could expand the brackets, but we don't need to. And on the right hand side, well, the half is going to get rid of, we're going to get rid of the half, because if we multiply 2 by half, that just gives us 1. So all we're left with is AT squared. We're getting closer. Now, final step is we want to get rid of that t squared. At the moment, we're multiplying by t squared, so we need to divide by t squared. So we need to divide both sides by t squared. So what we are left with 2 times s minus ut, all of that over t squared, and that is just going to equal a. As notice, the t squares will just cancel out. So we have made a the subject. So it doesn't matter which way round we put it. I've started putting the a on the left hand side. So this is just going to be a equals 2 times s minus ut, all of that over t squared. And again, like I said before, you can expand the brackets here, but we don't need to. Question 5. There are 120 people in the school canteen. 40% of the people in the canteen are Year 11 students. The number of Year 11 students in the canteen is 3 times the number of Year 10 students. The rest of the people in the canteen are Year 9 students. And we're also given the ratio. So the ratio of Year 9 students to Year 10 students is n to 1. Work out the value of n, and you must show how you get your answer. So this is only worth 2 marks, but there's quite a lot of text going on. So there's 120 people in total in the canteen, and 40% are Year 11 students. So to work out the number of Year 11 students, well, it's just going to be 40% of 120. So we can just do 120 multiplied by 0.4. And I don't need a calculator for that. I can see that that is going to be 48. There's 48 Year 11 students. And now we're told that the number of Year 11 students in the canteen is 3 times the number of Year 10 students. So to work out the number of Year 10 students, well, it's just going to be 48 divided by 3, because there's 3 times less Year 10 students. So it's going to be 48 divided by 3, and that gives us 16. So there are 16 Year 10 students, 48 Year 11 students, and now the Year 9 students, well, it just says the rest of the people in the canteen are Year 9. So whatever's left over from 120. So we can just do 120, take away the sum of 48 and 16. So 48 plus 16 is 64. If we take that away from 120, we get 56. And you can use a calculator to check that. But there should be 56 Year 9 students. So now we know how many students there are of each year group. We can have a look at this part. So it says the number of Year 9 students. So the number of Year 9 students to the number of Year 10 students. The ratio is n to 1. Now we know what the numbers are. So the number of Year 9 students, there are 56 Year 9 students, and there are 16 Year 10 students. So from this we can now work out what our missing letter is. So what n is. Now to do that, if we have a look, to go from 16 to 1, well, we just divided by 16. So if we do the same to 56, if we divide that by 16, that will give us our value for n. So we can do 56 divided by 16, and that gives us 3.5. So that is 3.5 So that is the value for n, and that's what it's asking us in the question, in the kind of the answer line. It says, what is the value of n? Or n is 3.5. It says you must show how you get your answer. Well, all of this is our workings out. Question 6. Amy drives 300 miles from London to Newcastle. She drives the first 165 miles at an average speed of 60 miles per hour. From this point, it takes Amy 3 hours and 5 minutes to complete her journey. What was Amy's average speed for the whole journey? Give your answer correct to 3 significant figures. So this is worth slightly more marks now. We've got a 4-mark question. So if we just think about what the journey is, we're going from London to Newcastle, which is my favourite football team, Newcastle United, and the distance is 300 miles. Okay, now she drives the first 165 miles, so let's say she's kind of travelled a bit further than halfway. So this distance here, she travels at an average speed of 60 miles per hour. So we can work out how long it took to go from London to this first point. So the time, and I'm just going to put in brackets first because it's like the first part of the journey. So how do we work out the time? Well, we think about the relationship between speed, distance and time, and I like to draw these triangles out. So speed is equal to distance divided by time. So if we're working out the time, well, it's going to be the distance divided by the speed. So the distance from here to here is 165 miles. 165 miles. And we're going to divide that by the speed, which is 60 miles per hour. 60 miles per hour. Let's get our calculator out. 165 divided by 60. That gives us 2.75. 2.75, and that is in hours. So the first part of the journey is 2.75 hours, or we could say that's 2 hours and 3/4. So 2 hours and 3/4 of an hour, which is, or 3/4 of an hour is 45 minutes. Okay, so the time it takes to go from London to here is 2 hours 45 minutes, and we're told the time it takes to go from here to Newcastle is 3 hours and 5 minutes. So to work out the total time, well, we can just add the 2 times together. So it's going to be 2 hours 45 minutes plus 3 hours and 5 minutes. 3 hours and 5 minutes. That will give us the total time. So 45 minutes plus 5 minutes, well, that's 50 minutes. And 2 plus 3 is 5. So it's 5 hours and 50 minutes. But let's put that in terms of just hours. Okay, like we had here, we had 2.75 hours. What is this value just in hours? Well, it's going to be 5 point something. And 50 minutes out of 60 minutes, well, that's just 50 out of 60. Or we could say 5/6. So instead of 5 point, let's say 5 and 5/6 of an hour. Okay, hopefully you can see that. It's 5 hours plus 50 minutes out of 60. So 50 out of 60 is the same as 5/6. That's 5 and 5/6 hours. That's the total time. Now we need to calculate the average speed for the whole journey. So the average speed is going to be the total distance divided by the total time. So the average speed is going to be the total distance, which we know is 300 miles. So 300 miles divided by the total time, which is 5 and 5/6 hours. And if we do that, our answer is going to be in miles per hour, which is quite nice because that's what we're after. So let's just put that into a calculator. So in the numerator, we've got 300. And in the denominator, we've got 5 and 5/6. Now be really careful when you're typing this into a calculator. Because if you just type in 5 and then the fraction 5/6, it's going to multiply the two together. So this is 5 plus 5/6. So 5 plus 5/6. And that gives us 360 over 7, or if we convert that into a decimal, well, that's going to be approximately, so if you just press the SD button on your calculator, that gives us 51.42857143. Okay, but it does say give your answer correct to 3 significant figures. So 3 significant figures, well, it's going to be 51.4. Okay, 1, 2, 3 significant figures. We look at the 2, but because that's less than 5, we would round this down to a 4. So it'll be 51.4, and notice our units are in miles per hour. So that is our answer, 51.4, 51.4. So I would just say that be really careful on this last bit. So you don't have to write 5 and 5/6 hours. You could also convert this to an improper fraction. So 5 times 6 is 30, 30 plus 5 is 35. So you could also write 35 over 6. So instead of writing 5 plus 5/6, okay, just to make it a bit easier, I'm just going to take that away. And let's say we use this instead. So 35 over 6. Just so you don't get confused with 5 plus 5/6 and 5 times 5/6. Because your calculator, you need to be really careful about what you type into your calculator. So putting it like this is probably a bit easier to do. Question 7. Potatoes cost £9 for a 12.5 kilogram bag at a farm shop. The same type of potatoes cost £1.83 for a 2.5 kilogram bag at a supermarket. Where are the potatoes better value? The farm shop or the supermarket? You must show you're working. So let's think about the farm shop first of all. So farm shop. So for 12.5 kilograms, well, that costs £9. And the supermarket, well, that for 2.5 kilograms, it costs £1.83. Now, at the moment, it's quite hard to see which one's better value. What we're going to have to do is we're going to have to equate the mass of the potatoes. So let's see how much it would cost at the supermarket if we were to buy 12.5 kilograms. So again, supermarket. So let's say we went to the supermarket and we bought 12.5 kilograms. How much would that cost? Well, to go from 2.5 to 12.5, we're multiplying by 5. And if you didn't know that, you could just do 12.5 divided by 2.5. So that would give us 5. So we know it's going to be 5 times as expensive, or 5 times the cost. So we need to multiply 1.83 times 5. So let's do that. 1.83 times 5, and that gives us 9.15. So it's going to cost £9.15. Now we can see which one's better value. And the farm shop is better value. So the farm shop is better value. And then we could put in brackets, £9 is less than £9.15. So it's 15 pence cheaper to buy it at the farm shop compared with the supermarket. Question 8. ABCD is a trapezium. Calculate the area of ABCD. So there's a few ways we could calculate the area of this trapezium. We could just calculate it outright if you know the formula for the area of a trapezium. Or what we could do is if I draw a horizontal line from C all the way till we get to this line here. So this is a horizontal line, and what we've formed is a rectangle and a triangle, and this is a right angle triangle because this line here is perpendicular to this line. So we can calculate the area of the rectangle, and then the area of the triangle, and then just add the two areas together. So let's first focus on the area of the rectangle. We know the width of the rectangle is 15, but we're not given this height here. So we need to calculate what this height is. So how are we going to do that? Well, what we can do is we can calculate this area. This length here. We can calculate this length. And then once we know this length, we can then calculate this length here. And how I'm going to calculate this length is I'm going to use Pythagoras' theorem. So we know this length is 15 centimeters because it's exactly the same as this length. And we know the hypotenuse is 17. So using Pythagoras, we can calculate this shorter leg. So let's just write down Pythagoras' theorem. So it's a squared plus b squared equals c squared. So all this means is if we square both of the shorter lengths and add them together, that gives us our hypotenuse squared. So if we just call this length x, so we know that x squared plus 15 squared is going to be equal to 17 squared. So let's just work out what they are. So x squared plus 15 squared is 225, and 17 squared, that is 289. So if we just take away 225 from both sides, we get x squared is equal to 64. And now if we square root both sides, we get x is equal to plus or minus 8, but we can't have minus 8 for a length, so it's going to be 8. So x is 8 centimeters. Now we can use that information to calculate BC. So if this total length from A to D is 12 centimeters and x is 8 centimeters, well, BC has to be 4 centimeters. I just did 12 minus 8. So now we've got the height BC, we can calculate the area. So 15 times 4, 15 centimeters times 4 centimeters. Well, that will give us 60 centimeters squared. So this is 60 centimeters squared. And now the area of the triangle, it's going to be the base times the height divided by 2. So it's going to be 15 centimeters times this length, which was 8 centimeters, and then divide by 2. So 8 divided by 2 is 4. 4 times 15 is 60. So that is also 60 centimeters squared. So to work out the area of our trapezium, we can just add the two areas together. So 60 centimeters squared plus 60 centimeters squared gives us 120 centimeters squared. And you might be thinking, well, they don't look the same. This area of the rectangle looks much bigger than the area of the triangle. But remember, this is not drawn to scale. Okay, so it is only a sketch. So this is the correct answer of 120. We don't need to write centimeters squared because it is already there. Question 9. Given that 81 times the square root of 3 equals 3 to the power n, find the value of n. So what we're going to have to do is we're going to have to write all of these numbers as powers of 3, and then we can use our laws of indices. So first of all, if we think about 81, how could we write 81 as a power of 3? So 81 is 3 to the power what? Well, it's 3 to the power 4. Because I know that 3 times 3 times 3 times 3 is equal to 81. And if you didn't know that, 3 times 3 is 9. 9 times 3 is 27. And then 27 times 3 is 81. So we can rewrite 81. I'm going to rewrite 81 as 3 to the power 4. And now the square root of 3. How can I write the square root of 3 as a power of 3? Well, whenever we take the square root of something, that's the same as raising it to the half power. These two things are exactly the same. So instead of writing it like this, I can write 3 to the power a half. Now we can use our laws of indices. So we have the same base. So what happens to our indices when we have the same base? When we multiply, well, we add them together. So we add our indices together. So this is going to be 3 to the power of 4 plus a half. Well, that's just 4.5. Or we could say 4.5. So n is 4.5. So find the value of n. N is equal to 4.5. So the key with these sort of questions is trying to make the bases the same. If you can make the bases the same, then you can apply your laws of indices to work out this number here. Question 10. There are 5 starters, 6 main courses, and X desserts. So we don't know how many desserts there are in the restaurant. Riley says there are 130 different ways of choosing a starter, a main course, and a dessert. Could Riley be correct? You must show your working out. So we know that there are 5 starters and 6 main courses. So let's first of all work out how many different combinations of starters and main courses there are. Okay, now to do that, well, there are 5 starters, and for every starter you can choose 6 different main courses. So the total number of combinations will be 5 times 6, which gives us 30. So there are 30 combinations of starters and main courses we can choose. Now to work out how many desserts there are, well, or how many combinations of starters, main course and desserts there are, well, we would just multiply 30 by x. So starters plus main courses plus desserts, well, that's just going to be 30 times x. So for example, if there was only one dessert, then there would only be 30 combinations, because from those starters and main courses you can't have any other combinations because there's only one dessert. If there were 2 desserts, well, for each of those 30 combinations there are 2 desserts, so there would be 60 combinations in total. So hopefully you can just see that it's 30 times x. So one dessert would be 30 combos. 2 desserts would be 60 combos. 3 desserts would be 90 combos. And you can see that Riley says that there are 130 different combos. So let's see if he could be correct. If we had 4 desserts, well, that would be 30 times 4, which is 120 combos. So if we had 5 desserts, well, 30 times 5 is 150 combos. So these are the possible combos he could have. So he cannot be correct because Riley says there are 130. So because the desserts needs to be a whole number, you can't have like 4.5 desserts. It has to be either 4 desserts or 5 desserts. Riley is wrong. So we have to write that down. Riley is wrong. And you must show all of your working. This should be enough to give us the 2 marks, but we could just put in brackets sort of 130 not divisible by 30. Question 11. The line AB passes through the points A, which has the coordinates -2k, and the coordinates 4, 8. And we're told that the gradient of the line AB is -2. Work out the value of A. And this is worth 3 marks, this question. So we know the gradient is -2. So we know the gradient. To work out the gradient, so to work out the gradient of a line, it's the change in y divided by the change in x. That is how we calculate the gradient. So if we look at our change in y, we're going from k to 8. So we could say that the change in y is going to be 8 minus k, the difference between these 2 values. And the difference between, and the change in x, we're going from -2 to 4. So that is 4 minus -2. Now we can simplify that. 4 minus -2 is the same as 4 plus 2, which is 6. So I'm just going to write 6 underneath here. Okay, so the change in x is 6. But we're also told what the gradient is. So we know that this has to equal -2. Let's write that down underneath. So 8 minus k over 6 is equal to -2. Now we have an equation we can solve to work out the value of k. So I think the first thing I'm going to do is get rid of this fraction. So if I multiply both sides by 6, so I'm just going to multiply both sides by 6. So that will just get rid of the 6 over here. So we'll just have 8 minus k on the left. And on the right, -2 times 6 is -12. So 8 minus something is negative 12. Well, I could work out that that is just going to be 20. 8 minus 20 is negative 12. But let's just do this properly, like algebraically. So at the moment, the k is negative. So I'm going to put it on this side. So I'm going to add k to both sides. I'm going to add k to both sides. So that's going to give me 8 on the left, because the k's will cancel. And on the right, we've just got k minus 12. Now, if our last step, if we add 12 to both sides, we get 20 on the left, and on the right, we are left with k. So k equals 20, and that's what it's asking us. Work out the value of k. K equals 20. Question 12. Expand and simplify this expression here. So we've got triple brackets. So the first thing to do is just focus on two of the brackets. So I'm going to just focus on this part of my expression. So x plus 5 times x minus 3. And I'm going to use the grid method for this. You could use FOIL, but I'm going to use the grid method. So we've got x plus 5 times x minus 3. So I'm just going to set up my grid like this. I'm multiplying each term in this bracket by each term in this bracket. So x times x is x squared. X times 5 is positive 5x. X times negative 3 is negative 3x. And negative 3 times 5 is negative 15. And we can simplify. So we've got a 5x and a negative 3x, which will give us 2x. So we're left with x squared plus 2x minus 15. So this expression here is the result when we multiply these two brackets. So now we've got this, and we're going to multiply it by our final bracket, which is 2x minus 1. 2x minus 1. And again, for this, I'm going to use the grid method. So I've got x squared plus 2x minus 15. And I've got 2x, take away 1. So again, if I set up my grid, okay, not the neatest, but doesn't really matter. So we're going to multiply everything in these brackets by, or everything in this bracket by everything in this bracket. So x squared times 2x, that gives me 2x squared. 2x times 2x, well, that will give me 4. Oh, sorry, I've made a mistake. So x squared times 2x is 2x cubed. Okay, x squared times x is x cubed. And so, yeah, be really careful with that. 2x times 2x, that does give me 4x squared. Now 2x times negative 15, that is negative 30x. X squared times negative 1, well, that is negative x squared. 2x times negative 1, well, that is negative 2x. And negative 1 times negative 15 is positive 15. And we can simplify again. So these two terms will simplify. So let's just write down what we've got so far. So we've got 2x cubed. These two terms, 4x squared minus x squared is plus 3x squared. And I can see that these two terms also simplify. So we've got negative 30x minus 2x, that's negative 32x. And then we've just got plus 15. And this is fully simplified. We can't simplify this anymore. So this is our final answer. Our final answer is 2x cubed plus 3x squared minus 32x plus 15. Question 13. We've got the two column vectors A and B, and we need to write down as a column vector A plus B. So we've got A, which is negative 2, 3, and we're adding on B, which is 5, negative 1. Now, whenever you add together column vectors, you just add the corresponding components. So you add the top values, which are the x components, and then the bottom values, which are the y components. So we've got negative 2 plus 5, which is 3. And then 3 add negative 1, or that is just 2. So our answer as a column vector is 3, 2. Now let's do part 2. So this time we've got 2A. So we've got two lots of A. So 2 lots of -2, 3. And we are subtracting B this time. So we're taking away 5, -1. So let's first of all deal with this. So if we've got 2 lots of A, we're just going to multiply each of the components by 2. So 2 times -2, well, that's -4. 2 times 3 is 6. So it's going to be, so this is 2A, and we're taking away B, which is 5, -1. So just like before, when we were adding the corresponding components, now we're subtracting the corresponding components. So -4 take away 5, that will give us -9. And we've got 6 take away -1. So be careful, we're not doing 6 take away 1, we're doing 6 take away -1. So that actually becomes 7. So that is our final answer as a column vector, -9 and 7. Question 14. A car's value is decreasing by X% each year. The car's value will decrease by 60% in 6 years. Work out the value of X. Give your answer to 2 decimal places. Now for this particular question, we're not given any information about the value of the car. The only information we're given is to do with the percentage decreases. So we start at 100%. So that's the car original value of the car. But it is being decreased by 60% after 6 years. So at the end of 6 years, it is now worth only 40% of the original value. Okay, because 100 minus 60, which is 40. So at the end of 6 years, it is now only worth 40% of the original value. So we started off at 100%. We need to multiply by some number, and we're doing that 6 times. So it's going to be some number to the power of 6, and that is going to equal 40. Okay, we just need to work out what this multiplier is, and then we'll be able to work out the percentage decrease. So we could just write this out as 100 times, let's just say m to the power 6. I've just used a random letter for this missing number, equals 40. So to work out what this is, what our multiplier is, if we first of all divide by 100, so we're left with m to the power 6 is equal to 0.4, and therefore m, well, we're going to take the 6th root of 0.4. So let's pop that into the calculator. Where is my calculator? It's over here. So we're going to do the 6th root, just try and find that on your calculator, of 0.4, and we get 0.85837. I'm just going to put ... Now this, be careful, this is not the percentage decrease. This is our multiplier. So to work out our percentage decrease, we just need to take this away from 1, okay, or 100%. So, I mean, if you think about what this is as a percentage, this is 85.837 ... percentage. So we're taking 85% of the original value. So how much is it being decreased each year? Well, we just do 100%, take away 85.837%. So let's put that into the calculator. So we get 14.1625 ... percent. So this is our percentage decrease. Now it says, finally, give your answer to 2 decimal places. Well, that is going to be 14.16%. That is our final answer. Question 15. A and C are points on the circumference of a circle centered O, and BC is a tangent to the circle. Probably going to be useful information going forward. We're also told that angle CAB, angle CAB, which is this angle here, is 29 degrees. We need to find the size of angle ABC, and we must show all of our working out. So first of all, what is angle ABC? So ABC, that is this angle here. Right, now this line here, BC, is a tangent to the circle. That's really important because we know that a tangent meets a radius at 90 degrees. So if I were to draw on a radius, I'm just going to do a dashed line for this. I'm drawing in a radius. It's not the best radius, it's slightly bent here. But if I draw in a radius, I know that this angle is 90 degrees. So let's write that down straight away. So angle OCB is equal to 90 degrees, and the reason is because a tangent meets a radius at 90 degrees. Okay, now what we've formed here, drawing this radius in, we've formed a triangle. And actually it's a special type of triangle because notice that this length and this length are the same because they are both radii. So I'm going to write this in. I'm not sure whether you need to write this in, but I'll write it in anyway. So AO is equal to OC. Okay, and the reason is because they are both radii. They're both radii. So what does that mean? Well, it means that this is an isosceles triangle. So because this is an isosceles triangle, this angle here is equal to this angle. So this angle is also 29 degrees. So we can say that angle OCA is equal to 29 degrees. And our reason is because base angles of an isosceles triangle are equal. Okay, now we've got this angle here. We've got three angles in this triangle. Obviously we're trying to work out this angle. Now we can work out this angle here. Okay, so this angle is going to be the 29 degrees plus the 90 degree angle. So I'm going to come up here now at the top of the page. So angle ACB is going to be equal to 29 degrees plus 90 degrees, which is 119 degrees. So this angle in blue that I've drawn in is 119 degrees. And now we're ready to calculate our missing angle. So angle ABC, well, it's going to be 180 degrees. Take away the sum of these two angles. So it's going to take away 119 plus 29. So 119 plus 29, that is 148. If we take that away from 180, we get 32 degrees. So our answer, find the sides of angle ABC, this is 32 degrees. And with this particular question, actually the reasons are probably less important than when we're proving something. So as long as you've shown the workings out, then you should still get 4 marks. But I've just included the reasons just to help you along and just to show you how I got each answer that I did. Question 16. The two triangles in the diagram are similar. So we've got this triangle here, ABE, and the larger one, ACD. They are both similar triangles. There are 2 possible values of x. Work out each of these values. State any assumptions you make in your working. Right, now whenever I'm dealing with similar triangles, I always like to draw them out separately. So let's do that. So we've got smaller triangle, looks something like this. Please forgive my drawings. So this is triangle A, not C, this is the small triangle, ABE, and we've got the larger triangle, which is going to be, let's do that again, a bit further this way. So this is triangle ACD. Now we're told that these two triangles are similar, but what we're not told is which side corresponds with which. So that's, I think, where the 2 possible values of x come from. So let's fill in kind of the length. So AB is 5, and we're told AE is 6. And for this larger triangle, well, we know this is 5 and this is 4, so AC must be 9. AC must be 9. And AD, well, that's 6 plus x. I'm not going to write that in. We don't know what it is. So these are the lengths we do know. Now, if we assume that these two lengths correspond with each other, so AB and AC, let's just highlight those. So let's assume that these two lengths correspond with each other. So we have to write that down. So if AC corresponds with AC, or if AC corresponds with AB, I should say, then what is the scale factor? So then the scale factor, we'll have to work out the scale factor. And the scale factor is, well, it's going to be 9 divided by 5. So how many times bigger is AC compared with AB? It's 9 over 5, or 1.9 divided by 5 is 1.8. Okay, so if these two sides correspond with each other, then we know that this triangle, the lengths of all of these sides are 1.8 times bigger than all of these sides. So if these two correspond with each other, then these two correspond with each other. And now we can work out what AD is. So AD, well, it's just going to be 1.8 times 6. 1.8 times 6, and that gives us, I think that's 10.8. Let me just verify that on the calculator. 1.8 times 6. Yep, 10.8. 10.8 centimeters. Now we know that AE is 6 centimeters. So ED or X, well, it's just going to be 10.8 centimeters minus 6 centimeters, which gives us 4.8 centimeters. So this is one possible value for X, but we need to be really careful because we just assumed that AB corresponded with AC. That might not be the case. So it could also be the case that AE corresponds with AC. Okay, so this triangle just could be flipped and rotated, and this length could correspond with this length here, and this length, let's do it in blue, this length in blue could correspond with this length. Okay, so with triangles, we don't know, we're not told which length corresponds with which other length. So let's write down our second assumption. So if this is a different case, so if AE corresponds with AC, then, well, the scale factor is going to be different now. Scale factor is, so we're saying that AE corresponds with AC. So how many times bigger is AC compared to AE? Well, it's 9 over 6. 9 over 6, or 1.5. So now we're saying our scale factor is 1.5. So to work out AD, so AD, well, it's just going to be 1.5 times bigger than AB. So 1.5 times 5, which gives us 7.5 centimeters. So now we're saying that AD is 7.5 centimeters. So to work out X, well, X is just going to be 7.5 centimeters minus 6 centimeters, which gives us 1.5 centimeters. So the two possible values for X, so we can say that X is equal to 4.8 centimeters or 1.5 centimeters. Okay, these are our two possible answers. And so we've given our two possible values for X, and we've also given all of our workings out and the assumptions that we've made. Question 17. Show that all of this business simplifies to this fraction where A, B, C and D are integers. Now, I know a lot of people don't really like these sort of questions, but I quite enjoy them. So let's first of all look inside the brackets here. So we've got x plus 4. We've got x plus 4. Now we're dividing by a fraction. whenever we're dividing by a fraction, that's exactly the same as multiplying by the reciprocal of that fraction. So that is the same as multiplying by, and we're just going to flip this upside down. So x minus 5, all of that over x squared minus 16. And you could think of x plus 4 as x plus 4 over 1, just so we've got two fractions that we're multiplying. And let's just put the multiplication symbol a bit further down, like that. Oh, wrong pen. So, like that. There we go. Now, whenever we're multiplying fractions that involve quadratics, we can simplify this by factorising. Okay, factorising is a really important tool to use when you're simplifying out fractions that involve quadratics. So let's factorise. We can factorise this part. Let's just highlight it or just circle it in red. We can factorise this. So how does this factorise? Well, this is a difference of squares. This factorises to x plus 4 times x minus 4. So I'm just going to rewrite this fraction again. So we've got x plus 4 over 1 multiplied by x minus 5 over x plus 4 times x minus 4. And now, because we've factorised, hopefully you can see that we've got an x plus 4 in the numerator and an x plus 4 in the denominator. So we can just cancel those out. They just cancel out, which is quite nice. So now when we multiply, well, we've just got 1 here. This effectively is just 1 times x minus 5, which gives us x minus 5. And in our denominator, we've got 1 times x minus 4, which is just x minus 4. So all of this business inside our square brackets simplifies to this here. And now we've got to add on 3. So we've got 3. I'm just bringing this 3 down. Here. We've got 3 plus this fraction. And now remember, you cannot add fractions unless the denominators are the same. So we're going to have to make the denominators the same. So our denominator is going to be x minus 4. So if we multiply this fraction by x minus 4 over x minus 4, it's just going to be, we're going to have 3 times x minus 4 over x minus 4. Hopefully you can see that this here is exactly the same as this, because look, the x minus 4s will just cancel out, so all we're left with is 3. Obviously I want my denominator to be x minus 4, so we've got that plus x minus 5 over x minus 4. And now notice we've got the same denominator, so we can just add the numerators together. So let's come up here now. So we've got, and actually I'm going to expand the brackets. So we've got 3x minus 12 plus x minus 5. And all of that is going to be over x minus 4. And we can simplify that. So 3x plus x, well, that gives us 4x. Then we've got negative 12 minus 5. That is negative 17. And then all of that is over x minus 4. And I think we are done. Yep, all of our A, so A, B, C, and D are all integers. A is 4. We don't have to write this down, but just to help you visualize what's going on. A equals 4. B equals 17. And it's not negative 17 because it's minus B, minus 17. C, well, C is just 1. Okay, that's 1x. And D, well, D is just going to be 4. So all of our letters are integers, so we have finished. So this here, I'm boxing. This is our final answer. Question 18. The diagram shows a triangular prism. The length CD is 20 centimeters. The length AD is 30 centimeters. And the angle FDC, which is this angle here, is 35 degrees. Calculate the size of the angle, the line AF. So the line AF is from here to here, so we're going to have to draw that line in. So what angle does that line make with the plane ABCD? So what angle does this line make with this plane, so this surface of our prism? And we need to give our answer correct to 3 significant figures. So the first thing I'm going to do is draw the line AF in. So let me get my line tool out. So the line AF is going to look like that. And now we need to be really careful about what angle we're measuring. Okay, we're measuring the angle that this line makes with this plane. Okay, so I'm going to draw another line from A that goes across this plane. So from A all the way to C. So it's going to be a flat line. So you can imagine it being kind of just going along the rectangle in line with the floor. So let's draw that. So from A to C. Okay, and now we're going to calculate the angle. Let me just draw it in. So this angle here. Oh, wrong pen again. So let's do that again. So this angle here, we're trying to calculate this angle. So what information do we already have? Well, we've got AD and we've got DC. So we can actually calculate AC using Pythagoras. Because this is a right angle triangle. It doesn't look, if we look from this perspective, this does not look like a right angle. But if we're looking directly from on top, we do have a right angle triangle because this is a rectangle. So let me just draw that in. It might be a bit clearer if I draw that in. Something like that. Let's do that a bit. I can do better than that. Like that. There we go. So we've got a right angle here. So we can calculate AC using Pythagoras. So AC squared, well, that's going to equal 30 squared plus 20 squared. So what does that equal? Let's type that into the calculator. So 30 squared plus 20 squared, and we get 1,300. But then remember, we need to square root that. Obviously, this length is not 1,300 centimeters. That'd be a bit crazy. So AC is going to equal the square root of 1,300. So square root answer, and we get 10 root 13. 10 root 13 centimeters. Now we could write this as a decimal, but I don't want to lose any accuracy. So I'm just going to keep this as a surd. So this is 10 root 13. What else can we calculate? We can also calculate FC, because notice we focus on this triangle over here, FDC. We've got the angle, okay, we've got this angle here, and we've also got this length. So now we can use SOHCAHTOA to calculate FC. So let's just write down SOHCAHTOA. SOHCAHTOA. So from the perspective of our 35-degree angle, well, this is going to be the opposite side length, and this is going to be the adjacent side length. So which trig function involves the opposite and the adjacent? Well, it is the tan function. So we're going to use the tan function to work out FC. So let's just write down the definition of tan. So the tan of an angle, in this case it's our 35-degree angle, but it's going to equal the opposite divided by the adjacent. So it's the opposite divided by the adjacent, which we know is 20. So now to work out the opposite, we can just rearrange this formula. So the opposite side length is going to equal 20 times the tan of 35 degrees. So let's work out what that is. So 20 times tan of 35, and we get 14.00. So that's quite nice. I'm just going to round that to 14. So 14, and that is in centimeters. 14 centimeters. So our opposite side length we can now write in is 14 centimeters. Right, now we can calculate this angle, because notice we've got a right angle triangle. This is another right angle triangle. It might not look it's quite hard to see from a 3D kind of in a 3D solid all of the right angles, but this is a right angle triangle. Let me draw that in. Quite hard to see, but this is a right angle triangle because this is a vertical line and this is a horizontal line. So we can use SOHCAHTOA again to calculate this angle. So it doesn't have a label. Let's just call it theta. So first of all, which trig function are we going to use? Well, from the perspective of this angle, this is still our opposite side length, and again this is our adjacent side length. So we're still going to use TOA. We're getting quite used to using our tan function now. So let's do this. So the tan of our angle, this time we don't know the angle, that's what we're trying to work out. So the tan of our angle is equal to the opposite, which is 14, divided by the adjacent, which is 10 root 13. So to work out the angle, well, we just take the inverse tan. So our angle is going to be the inverse tan of 14 over 10 root 13. And now we can type this into the calculator. So shift tan 14 over 10 root 13. And again, be careful when you're typing this into your calculator. And we get 21.22 degrees. 21.22 degrees. And that looks about right. If we do a dummy check, this is quite a small angle. It's obviously not drawn to scale, but I think this looks like a reasonable answer to give. Give your answer correct to 3 significant figures. Well, that's going to be 21.2 degrees. Question 19. The table shows information about the time in seconds taken for some people to run a 100-meter race. So if we look at the table, it looks like there were 6 people who ran the 100 meters in a time between 10 and 12 seconds, which seems quite quick to me. There were 21 people who took between 12 and 13 seconds. The only bit of information we're not given is how many people it took to run 14 to 16 seconds. So part A, use the information on the table, so what information we do have, to complete the histogram. So you can see that our histogram is not yet completed. We've only got 2 bars, and we've got 5 bars to do in total. So we need to fill in the extra bars using this information here. So now on the really important thing is on a histogram, our y-axis is not frequency. You might be tempted just to write frequency down here, but so time on the x-axis, this is frequency density. I'm just going to write it up here. So frequency density. Okay, so we need to calculate the frequency density for each of our time intervals and then plot them on our histogram. So how do we calculate frequency density? That's the first thing to think about. How do we calculate frequency density? Well, the formula for frequency density is for each category, we take the frequency. And we divide that by the class width. And what I mean by the class width in this case is just the time interval. Okay, so the first one, the class width is 2 seconds, and the frequency is 6. So 6 divided by 2 is 3. Let's just write up here frequency density. The next one, we're going to have 21 divided by 1, which is 21. The next one, we've got 23 divided by 1 again, which is 23. We can't do this one yet. And the last one, we've got 8 divided by 4, which is 2. So these are our frequency densities. We have to plot them on our histogram. And now we can use this bit of information here to fill in our axes, because we know that the frequency density for this category, the 16 to 20 category, is 2. So we know that this point here must be 2. Okay, and with that we can now fill in all of our unit or all of our numbers on our y-axis. So if this is 2, well, this is going to be 5, because you can see that 1, 2, 3, 4 for every 2 small squares, every 4 small squares, our frequency density is half of that. So 10 small squares, our frequency density would be 5. So this is 10, this is 15, this is, I'll write 16 there, but no, this is 20, and this is 25. So now we've got our axis, we can fill in our our histogram. So I'm going to get my line tool out for this. So let's do the first one. The first category, 10 to 12, we're going all the way along from 10 to 12, and we're going to go up to 3. So if this is 2, this is going to be 3. So let's just draw another line along to the end. There we go. That's our first category. Our second category has a frequency density of 21. So we're going to go all the way up, and actually it's exactly the same as this one here. Oh, I'm just going to get rid of that and do it again. So let's do it again. So this is 20 and this is 21. And that's good enough. That's 21. So now let's go along. Be really careful. I'm not going to go all the way along to the end because it is only 12 to 13. So 12 to 13 is here. Now let's come back down to the bottom. Okay. Now let's look at the next one. So the 13 to 14 category, frequency density is 23. So we're going to have to go up. So that's 22. That's 23. And let's go along. Apologies if I'm taking a bit of time over this. It's just I'm a bit slow with the line tool. Okay. And that's it, because the other ones are already done. So we have done part A. We've used the information on the table to complete the histogram. And now part B, use the histogram to complete the table. Well, there's only one bit that we haven't filled in yet, or one space left. And we can see what the, well, first of all, we can see what the frequency density is. Okay, because that's for this category here. So the 14 to 16 category is this box here. That's the 14 to 16 category. So what is the frequency density? Well, it's the same as the 12 to 13 category. It is 21. So our frequency density is 21. And now we know the frequency density, we can calculate the frequency. So how do we calculate the frequency? Well, we just need to rearrange this formula. So if we rearrange this formula, we get that the frequency is equal to the frequency density multiplied by the class width. So the frequency is going to be 21 times our class width, which is 2. 21 times 2 is 42. Let's just write that down here. So I did frequency density, which was 21, multiplied by our class width, which was 2, which gives us 42, and we are done. Question 20. We've got the formula f equals the square root of g over h, and we're told what g is to 3 significant figures, and we're told what h is correct to 3 decimal places. By considering bounds, work out the value of f to a suitable degree of accuracy. Give a reason for your answer. So we need to consider both the lower and upper bounds for our 2 values. So let's do that first. Let's think about what the lower bound of g is. Okay, so remember we've rounded g to 3 decimal places, and our answer is 12.7. So the lower bound for g, well, that's going to be 12.65. If we round this to 3 significant figures, the 5 tells us to round the 6 up to a 7. So that's the lower bound for g. Now the upper bound for g, well, it's just going to be the same distance away, but just in the other direction. So it's going to be 12.75. Now let's think about h. So the lower bound for h, well, this time we're rounding to 3 decimal places. So it's going to be 9.2935. And again, remember, the 5 tells us to round this up to a 4. So that will take us to 9.294. And the upper bound, again, it's exactly the same distance, but in the other direction, it's going to be 9.2945. So now we've got our lower and upper bounds. We can, let's think about the lower bound of f. So the lower bound of f. So think about what's the smallest number this could possibly be. Well, to get this as small as possible, g is going to have to be as small as possible, but h is going to have to be as big as possible. So we're going to find the lower bound. We're going to do the lower bound for g divided by the upper bound for h. And I'll do that in a moment, but let's just think about the upper bound for f. The upper bound for f, well, that's going to be the opposite. To get the biggest possible number, we're going to have to get the upper bound for g and the lower bound for h. We're going to take the upper bound for g divided by the lower bound for h. So let's first of all do the lower bound of f. So it's going to be the square root of the lower bound of g. Well, the lower bound of g is 12.65. 12.65, and we're going to divide that by the upper bound of h. Well, the upper bound of h is 9.2945. So let's get our calculator out. So square root of 12.65 over 9.2945, and that gives us 0.382. I'm going to write down everything. 665,431. So that is the lower bound of f. Now let's do the upper bound of f. So it's going to be the square root. This time we're taking the upper bound of g, which is 12.75. And we're going to divide that by the lower bound of h. So this time it's this one here. 2935. Again, let's put that in the calculator. So the square root of 12.75, and then we're going to divide that by 9.2935. And I get 0.38421. 630.33. So these are my two answers. So we know that the answer has to be between these two answers. Now we can only give one value. It says work out the value of f to a suitable degree of accuracy. Now we need to round these numbers. So let's think about being not very precise to begin with, and let's try and get more and more precise as we go. So 0.4. Hopefully you can see that both of these numbers round to 0.4, so that would work. So if we said the answer was 0.4, we wouldn't be wrong, but we could get more accurate than that. Okay, we could be a bit more accurate. Let's say, so both of these numbers, if we round to 2 decimal places, notice they both round to 0.38. Okay, this is 382 and this is 384. They would both round to 0.38. Can we get even more accurate than 0.38? Well, this time we'd have to go to 3 decimal places. This one would be 0.383 because we would round this 6. This 6 will tell us to round the 2 up. This one would be 0.384. 0.384 because the 2, I'll just put the line in here, the 2 will tell us to round this down. So we can't round to 3 decimal places because we get different answers. Okay, so our answer is going to be 0.38. Now we have to give a reason as to why we've given this answer, and we can say that both the upper bound and lower bound round to 0.38. So this is our reason. Both of our answers round to 0.38. So this is the most suitable, would be the most suitable answer to give for our answer for F. Question 21. Here are 2 right angle triangles. Given that the cos of A equals the cos of B, find the value of X. You must show your working. So how do we calculate the cos of an angle? So if we think about SOHCAHTOA, let's just write SOHCAHTOA. Oh, let's not do it in yellow. That's very silly. Do it in purple. So if we think about SOHCAHTOA, what is the definition of cos? Well, cos is the adjacent divided by the hypotenuse. So we're going to focus on this trig function. So we know that whenever we divide the adjacent by the hypotenuse in both triangles, we get the same value. Okay, so the adjacent divided by the hypotenuse in this triangle is equal to the adjacent divided by the hypotenuse in this triangle. Okay, so what is the adjacent? Well, in this triangle, the adjacent is x. So it's going to be x divided by the hypotenuse, which is 4x plus 3. And we know that that is equal to the adjacent in this triangle, 3x plus 2, divided by 27x plus 4. And now we just have an equation to solve. Okay, so the hardest bit is actually trying to interpret the question and write down your first line of working. And hopefully this makes sense. This is the cos of A, the adjacent divided by the hypotenuse. This is the cos of B, and we're saying that they equal each other. So let's multiply. Let's do the cross multiplication. So I'm going to multiply both sides by 27x plus 4. So we're going to have x times 27x plus 4 equals, and then we'll multiply both sides by 4x plus 3. That's going to be 4x plus 3 times 3x plus 2. So now if we just expand the brackets, so here over this side we've got 27x squared plus 4x, and that equals, I'm just going to FOIL this out, so 4x times 3x is 12x squared, 4x times 2 is plus 8x, 3 times 3x is plus 9x, and then 3 times 2 is plus 6. Now let's do a bit of simplification. If I take away 12x from both sides, then we're left with 15x squared plus 4x. And on the right hand side, well, we can just simplify these two terms. 8x plus 9x is 17x plus 6. And now, in order to solve a quadratic, we're going to have to get everything on the left hand side, and it's going to have to equal 0 on the right hand side. So if we subtract 17x from both sides, we're left with 15x squared minus 13x. Now if we take away 6 from both sides, we've got minus 6, and that equals 0. And now we can solve this quadratic. So first of all, can we factorize? Well, I think probably the easiest thing to do, just to save a bit of time, is just to plop everything into the quadratic formula. Okay, so let's just write down what the quadratic formula is again. I'll put it up. There's not much space here. I'll put it up here. So x equals minus b plus or minus the square root of b squared minus 4ac, all of that over 2a. So what are our values for a, b and c? I'll just write it down here. So a is 15, b is negative 13, and c is negative 6. So we're just going to substitute these values into our formula. So x is going to be negative b, well, negative 13, that's just going to be positive 13, plus or minus the square root b squared, so negative 13 squared, minus 4 times a, which is 15, times 15, I'm just going to write that out again, it's a bit messy, 15 times c, which is negative 6. And all of that is being divided by 2 times a. 2 times 15 is 30. So let's work out what our answer is. So I just need to get my calculator out now and type all of this in. So 13. There's going to be two solutions because we've got plus and minus. Let's do the plus first. So the square root of negative 13 squared and minus 4 times 15 times negative 6. All of that divided by 30. Oh, we get a nice answer actually, 1.2. So 1.2, or let's just change the plus to a minus. Minus 1/3. Okay, now there's two answers. Let's go back to our diagram because one of these answers doesn't make sense. If we think about this answer here, negative 1/3, we cannot have a negative length. That is just nonsensical. So our answer, we're only going to have one answer, and our answer is going to be 1.2. So find the value of x. X equals 1.2. Question 22. Solve algebraically the simultaneous equations. So we've got one quadratic equation and one linear equation. So in order to solve this, what we're going to do is, first of all, if we make x the subject or y the subject, doesn't really matter which one, but let's make x the subject. Once we've made x the subject, we can then substitute that expression for x into this quadratic equation, which we can then solve. So I'm going to first focus on this second equation, and I'm going to make x the subject. So if I just copy it out down here, so we've got 2x plus 3y equals 4. So if I subtract 3y from both sides, I get 2x is equal to 4 minus 3y. And now if I divide everything by 2, I'm left with x is equal to 2 minus 3 over 2, not 3 over y, 3 over 2y. Okay, and now I've made x the subject, I can substitute this expression for x into my first equation. So instead of writing x squared, I can do all of this squared. So let's do that. So we've got 2 minus 3y, 2 minus 3 over 2y, all of that squared. So all I've done is I've just replaced x with this expression, minus 3y squared equals 13. So let's expand the brackets. So we'll just make things clearer. Let's just write this as a pair of double brackets. So 2 minus 3 over 2y times 2 minus 3 over 2y. Just think it makes it a bit easier to understand if I write it out in full. I'm just copying everything else out. So now let's just FOIL everything out. So 2 times 2 is 4. 2 times negative 3 over 2y, well, that's negative 3y. Now if we do negative 3 over 2y times 2, well, that's the same. That's another minus 3y. And finally, negative 3 over 2y times negative 3 over 2y, well, that's positive 9 over 4y. And then we've got minus 3y squared equals 13. So we can do a bit of simplification now. What can we, well, minus 3y minus another 3y. Oh, I've just made a mistake. I've realised, sorry, that this should be 9 over 4y squared. So 3 over 2 times 3 over 2 is 9 over 4, but then we've got y times y, which is y squared. So I just made a small mistake there. Okay. So we can simplify the two. Oh, excuse me. Sorry about that. It wasn't important. So negative 3y minus 3y, well, that is negative 6y. So we've got 4 minus 6y. And now we can simplify these two terms. We've got two y squared terms. Now I can see that 3 is the same as 12 over 4. So 3, I'm just going to change the 3 to a 12 over 4. And that's the same as 3. The reason I've done that is because if we've got 9 over 4, take away 12 over 4, that is minus 3 over 4. So minus 3 over 4 y squared, and that equals 13. Right, so we're getting closer now, but we've got a fraction here. If we want to get rid of this fraction, we can multiply everything by 4. So if we multiply everything by 4, that gives us 16 minus 24y minus 3y squared equals 52. Now I don't like this negative 3y squared over here, so I'm going to move this to the other side. So that becomes 3y squared. If I move this over to the other side, that becomes plus 24y. If I move this to the other side, that is minus 16. Therefore, the 52, I'm going to move that to the left-hand side. That now becomes minus 52. And now to solve any quadratic, we need to get 0 on one side. So if we add 52 to both sides, we've got 3y squared plus 24y. Now if we add 52 to 16, that gives us 36. So plus 36, that equals 0. Now I can see that we can divide everything by 3. So that gives us y squared plus 8y plus 12 equals 0. And there are a few ways we can solve this. We could use the formula, but what I'm spotting is that we can factorise this quadratic expression. Because if we want to find two numbers that multiply together to get 12 and add together to get 8, well, we can use 6 and 2. So we can factorise this, and let's just do it up here. So this expression here factorises to y plus 6 times y plus 2, and that equals 0. So therefore our two solutions are y equals negative 6 or y equals negative 2. So these are our two solutions for y. So now we've got our values for y, we can substitute these values for y into one of our equations to work out the corresponding values for x. And it doesn't matter which equation we choose, but I'm going to choose the linear one just because it's going to be a bit easier. So let's first of all do when y equals negative 6. So we're going to have 2x plus 3 times negative 6, and that equals 4. So that gives us 2x, and then 3 times negative 6 is minus 18 equals 4. So then if we add 18 to both sides, we get 2x is equal to 22. Therefore, x equals 11. So when y equals negative 6, x equals 11. Now let's do when y equals negative 2. So we're going to have 2x plus 3 times negative 2, and that equals 4. So now if we just simplify, 3 times negative 2 is negative 6 equals 4. We add 6 to both sides, we get 2x is equal to 10, therefore x equals 5. So we've got our two pairs of solutions. So we can say x equals 5, not 5, sorry, let's do this one first. X equals 11 and y equals negative 6. Or we could have when x equals 5 and y equals negative 2. Question 23. There are some red counters and some blue counters in a bag. The ratio of red counters to blue counters is 3 to 1. Two counters are removed at random. The probability that both the counters taken are blue, so both of the counters that are removed are blue, is 1 out of 20. Work out how many counters were in the bag before any counters were removed. Now, if we first of all look at this line here, it says the ratio of red counters to blue counters is 3 to 1. So we can use this. Now, we don't know how many counters there are in the bag at the moment, but we do know one thing. We know that it must be a multiple of 4. Okay, because the ratio is 3 to 1. So for every 4 counters, 3 of them are red and 1 of them is blue. So the total number of counters must be a multiple of 4. So we can say that the total number of counters, we can write an expression for that. We could say is 4n. For example, there could be 8 counters, 12 counters, 16 counters. So 4 times n for an expression for the total number of counters. Let's write an expression for the number of red counters. So how many red counters will there be? Well, there's going to be 3n. Okay, there's going to be 3n red counters, and blue counters, well, there's just going to be n blue counters. Okay, notice that if we add these together, we get 4n. 3n plus n is 4n. So now we can write an expression for the probability. So the probability that both the counters taken are blue is 1 over 20. So let's first of all write an expression for the probability. So what's the probability of selecting one counter that is blue? So we go and reach in our bag and we pick out a counter. What is the probability that is blue? Well, it's going to be 1 out of 4. Because out of every 4, 1 is blue. So the probability is going to be 1 out of 4. And now we need to multiply that by the probability of picking another counter that is also blue. But it's not going to be 1/4, because when we take out a counter, there's going to be less in the bag. We don't put it back in. So first of all, how many blue counters are there now in the bag? Well, there was n, so there's going to be now n minus 1. We're losing one blue counter. And how many total counters are we now left with? Well, we started off with 4n, but again, we're taking away 1, so it's 4n minus 1. So let's work out what this is. So 1 times n minus 1, well, that just gives us n minus 1. And our denominator is 4 times 4n minus 1. That gives us 16n minus 4. And we know this is an expression for the probability. We know the actual probability is 1 over 20. So we can write that this equals 1 over 20. And now we can just solve this equation. So I'm going to cross multiply. So 20 times n minus 1 is going to be 20n minus 20. And if we do 16n minus 4 times 1, we're just left with 16n minus 4. And now if we subtract 16n from both sides, we're left with 4n minus 20 equals negative 4. And if we add 20 to both sides, we get 4n is equal to 16. And therefore n is equal to 4. So we've worked out what n is. The question says work out how many counters were in the bag before any counters were removed. So n equals 4. The total number of counters we said was 4n. So 4 times 4 equals 16. So our answer is 16. And we can double check that. Let's just double check that if there are 16 counters, the probability is 1 over 20. So there's 16 counters and there's 4 blue counters. So it's going to be 4 over 16 multiplied by, we're going to take out 1 blue counter. So we now have got 3 blue counters in total. And we've got 15 counters in total. So 4 over 16 times 3 over 15. Well, that is the same as 1 over 4 times 1 over 5, which is indeed 1 over 20. So 16 is the correct answer. So we've now come to the end of this particular video, and we've also come to the end of this series of videos on GCSE walkthroughs. So just to recap, I did 2 of the foundation walkthroughs, both paper 2 and paper 3, and I've also done 2 of the higher walkthroughs, paper 2 and paper 3. So thank you very much for watching. I hope this is really beneficial for you for your upcoming exams. Good luck, and hopefully I'll see you soon. Take care.